In problem 1.2, we're looking at rotation symmetry. So remember, there's three types of symmetry. There's translation symmetry, reflection symmetry, and rotation symmetry. We've already looked at reflection symmetry in problem 1.1, where you can just fold an image over onto itself. And sometimes objects that have rotation symmetry also have reflection symmetry. But today we're going to just look at the rotation part of that symmetry and see. The question here is, when you have rotation symmetry, how much do we have to turn the image before it looks like it started out? So you see this pinwheel here. If I just turn the book, you see that in different points it looks like it originally did. So it's hard to tell just from rotating the book without a point of reference. So I'm actually using a piece of transparency paper here, and so if I mark this spot, you can see that if that spot is rotated, like I'm rotating over the image that much, then the image itself would be on itself, or if I actually rotate the book underneath it. So if I keep that spot where it is and I rotate the book like that, then I get the original image back. Another way to think of it is if I just take and make a line all the way through the image to the center point. So from there to there, and then I rotate the image until I'm at the new point here. And so that, again, now was the original point, and I actually can take this point of reference, this angle really is what I'm looking for. Is that angle is how much I have to rotate the image each time before it's back to its original shape. So I could actually take that and move it all the way around the circle in different points. And so what I want to look at is, what is that angle of rotation? What angle do I have to move it to in order to get to that point? So I'm actually going to take an angle ruler in this case. And if I take my angle ruler and set it on this and open it up till it's equal to that angle that I had in there, and I look at my angle ruler measure, we can't see it very well in this image, and I look at that angle ruler measure, it measures 45 degrees. So that space in there is a measure of 45 degrees. And so that's the angle of rotation, and each one of these angles is 45 degrees. So I have 45 degrees, 45 degrees. Each space represents 45 degrees. And be good to note that if you take all of those 45 degrees, so we have 90, 180, 270, the total distance around that is 360 degrees. So to make an entire rotation, each of those 45 degree turns, after each 45 degree turn, I'm back to the original place of the image, and that gives me the total distance all the way around, which makes sense because if you go in a complete circle, you've gone 360 degrees. So each of those turns, each of those rotations is 45 degrees, and that's my angle of rotation symmetry for that particular image. And so if we look at the three images below, we have a windmill picture, a kaleidoscope, and a snowflake picture, and we also have a wagon wheel picture. And in each case, you can see that they have rotation symmetry, and I can identify that rotation symmetry really with the windmill by thinking of this being the center of the windmill being the center point, and each arm of the windmill being a point of rotation symmetry. So if I just look at the windmill portion of it, you can see that the angle of rotation symmetry for this, if I take my angle ruler, and I think you probably without the angle ruler you can see that that represents an angle of 90 degrees. So I have a 90 degree angle of rotation for the windmill. If I continue on to the snowflake, it's a little bit harder, but again you can see there's a center point, and there's often points that are visible and obvious. And so if I go each of those points, and you notice that oftentimes they go right through to the other side. And if you think about this one, I could use my protractor to measure, or I can recognize that there's 1, 2, 3, 4, 5, 6 angles. In other words, this has 6 rotations before it's back to its original. And if you take 360 degrees divided by those 6 angles, then each of those angles has to be 60 degrees. So I have an angle rotation of 60 degrees, 60 degrees, 60, 60. So if you put all those together, 60 times 6 is 360 degrees. Just like these 90s, 90, they all add up to 360 degrees. Or I could have gone 360 degrees divided by 4 equals the 90 degrees. Which makes the last one a whole lot easier to deal with, because if you can see this, there's a lot of angles. If I rotate this wagon wheel, each of these spokes of the wagon wheel is one rotation line of symmetry. And you can see I can keep going around. There's all of these spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 different parts. In other words, I can divide this wagon wheel up into 12 equal spaces, or 12 rotations. So if I take my 360 degrees divided by those 12 rotations, then each of those angles is 30 degrees. And so each angle of rotation in this case is 30 degrees. So the wagon wheel has angle rotation of 30 degrees. So those are all the turns that we can make and still have rotation symmetry. And really, to some extent, you could think of, I could rotate this one 60 degrees and see it again, or I can rotate it 120 degrees, or I can rotate it 180 degrees. So I could actually list a whole bunch of angles of rotation for each of these images. It's not just the 60 degrees brings me back, but I could go 60, 120, 180. So it could keep going all the way through all the different angle measures with the different sets of 60. Or even 90, 180 would give me a back to the original image, 270, or all the way around 360 degrees. So you actually have, in this case, all these 90, 180, 270, and 360 are all your different rotations for the windmill that will bring it back to its original shape. And again, with these, there's a whole bunch: 60, 120, 180, 240, 300, and 360 degrees. All of those angle measures, any of those rotations of any of those degree will bring this back to the original that we see here. And again, here you have even more with 30 degrees each. So I have 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360 degree rotations. All of those rotations, all of those different amounts will bring this back to its original shape anytime we rotate it 30 degrees and more. So we have our center of rotation, center of rotation, center of rotation, angle of rotation, angle of rotation, angle of rotation. So when we describe symmetry for rotation symmetry, we do it in two ways. We describe it by the center of rotation, so where the center of that image is, and by the angle that we rotate it, the smallest angle through which you can turn it and it still looks the same. So we have the fixed point in the center, and we have the angle of rotation that you move it in order to get to the next image. And that's really just the first part of problem 1.2. We've actually answered questions A and B, and we can move on to really question D over in the problem 1.2, which is what we're going to do in the next lesson. So if you want to find more about problem 1.2 questions D and on, then go to the next lesson.